Thank you, everybody, for being here. We're going to talk about lots of interesting things today. We're going to talk about space and how space can help you with your business. What does that mean? Well, you're using space in your day-to-day lives. Your mobile phones, they cannot survive without satellites. You cook a meal on a Tefal plate, that's a spin-off from space. So today, I would like to welcome on stage some of our amazing speakers. First come is Jan Prax from Aalto University. Give a big round of applause. Hi. Then we have Tauro Varaste from ICEI. Woo!
Hello.
Great
hello,
job.
Hello.
And we're also going to be joined by Vitanes Buzas from Nanoavionics Online. So without further ado, let's jump into space.
Thank you.
Great. So, Jan, tell me more about your job. So you're assistant professor at the Aalto University, and from what I understand, you interact a lot with students, and you see some innovative ideas here and there. And how do you foster this mind games of innovation, and how do we get from innovation to actually companies?
Sometimes it's a long road, sometimes it's a short road. Actually, I have a small presentation about it, but should I present it now or a bit later? But yes, it's a fascinating topic, and space is open for innovation and business, and there is a lot of things happening right now.
Perfect. Well, let's try and start your presentation, and let's hear all about it.
So, my presentation is titled Aiming High from Academia, and first we should think like, why academia? What does it have to do with space? So, I argue, let's see, do I have also my slides advancing? They do not advance. All right. So Finland is quite a new space country. First satellite was launched 2017. This is only 4 years ago. So what can you expect from this kind of country, which was launching its small satellite, student-made 4-kilogram satellite just 4 years ago? This is really, really not very much. But if we take a look today, what is happening in the space field in Finland? So this is the register of Finnish spacecraft, Finnish space objects in space right now. And you see Aalto student-built satellite from our university is the first one proudly. And now we have a long list already, 16 satellites, and this number is growing very, very fast. So we have different kind of technologies already. We have small companies who are building CubeSats, making space weather missions with these CubeSats. They are making very advanced communication missions with very high frequencies, W-band. We have companies who are making a really innovative propulsion systems for, again, very small satellites. We have companies which are building educational satellites which can be used for students to take a look what is a CubeSat, what is a satellite, how we should do space. We have companies who are making the first missions with a wooden satellite. Can you imagine? A satellite made partly out of wood, and this kind of innovation scene is going on. Many small companies making satellites, and then, of course, Tero, we have ICEI, a company which has been growing and changing the whole commercial remote sensing in Europe. They are having absolutely staggering capability. They are making most beautiful SAR scenes, synthetic aperture radar scenes I ever seen before. So what do we do in Aalto University to grow these kind of businesses? Because all these 16 satellites at the moment in space in Finland actually have their roots in Aalto University. There are 3 or 4 actual Aalto University satellites, but then we have a lot of startup companies who are building their satellites, and they are all born from Aalto University. Let's take a look what you have to do in order to plant a plant. So how to grow a plant? Here we have a very pure form of plant in space. So what does it need? First, it needs a seed. When we have to have some minerals in order to feed this seed with things to grow. Then we have water. We have to have water as well. And then finally, we have to have light. And I have been extending this concept here, just to explain how it should work, to startups. So what we need to have first is talents. We need people. We need students who are doing this thing. We need knowledge, and knowledge is, of course, available in a university. We need resources, so these students should practice, they should have material to play with, they need to have their toys to study and to learn. And then finally, the light. We need also inspiration. We need people, we need community, which is having the ideas, bringing these ideas forward, and dares to dream. So, additionally, we need a freedom and place to grow, and I claim that this place is a university. So university is a universal playground for high technology, young people and resources. So if we take a look of our toys, we are building really small satellites which are rather simple, and generations and generations of students, they have been going through this process and trying to build their own space mission. So here you can see how they dream, how they build, what is everyday life. It's nothing very, very tricky. And as you can see here, the big company CEOs are here on these pictures, rather young and, let's say, inexperienced at this moment, but it's growing bigger. So why we have these success stories? Do we have an exceptionally good university? I claim that we don't actually have. But we have excellent people. And these are these young people who are coming to university, having their dreams, their ideas, they're getting in touch with inspiration and knowledge and some resources, and magic will happen. But we shouldn't stop here. We need to go much further, because we need to teach engineering in a global, planetary level. So the space age needs space engineers, and we need to support universities in order to make this happen. Our planet needs care. Our planet needs space technology. Otherwise, we cannot handle such a big system. We need to develop different kind of global satellite systems, global assets, which can be used to tackle, for example, global warming and all the other ill effects what we have been causing to the planet as humankind. So, I stop here and say that the biggest adventure of humankind has just started, and I hope, and sincerely hope, that universities will be the greenhouse where all these wonderful ideas have a possibility to grow in order to tackle the problems and conquer the world. Thank you very much.
Thank you so much, Jan, for this amazing presentation. So if ever you have any questions for Jan or for any of the panelists, please use the online tool and that I will see then for your questions. Next up is Vytenis Būzas, who is joining from Lithuania. So hi, Vytenis. It's a pleasure to have you with us today. So you're the CEO and the co-founder of NanoAvionics. Your company has grown from a small team as a spin-off of Vilnius University and now has more than 100 engineers over the UK, the US, and in Lithuania. Some people might say that you're one of the fastest growing companies in space in Europe these days. What's the secret to your success, and what were maybe the obstacles that you faced? So tell us all about it.
Yeah, thank you. Thank you for introduction. Hello, everybody. I'm sorry I couldn't join you today, being there, but I hope you can hear me well, and I will try to explain, and I will reveal all of the secrets as you just requested. Okay.
Awesome.
So yes, my name is Vytenis. I'm joining the conference from Vilnius, from Lithuania, and I want to prove you today that yes, we can do business from the relatively small countries like Lithuania, and we can compete globally. And our area is nano satellites. So yeah, first of all, I will explain you where we are right now, and by the end of the presentation, I will give you, some information how we started this business. So yes, very shortly, our aim is to be the global leader of nanosatellite world. Let's say we are seeking to become an Airbus or Volkswagen Audi group of the nanosatellites. Everything was started in 2014 after our first Lithuanian CubeSat has been launched. We've been there working under universities, but at some point after the successful mission of the first Lithuanian CubeSat, we started to think with my colleagues where we would like to go now. And there were two options, right? One option is academia, another option is business. So we decided that academia is very interesting and, it can kind of feed the curiosity, right? Because you can do a lot of research in various areas. At that moment, I was working with nanosatellite, nanosatellite focused propulsion. But after some consideration, we decided to go with business because after all, it provides much more risk, but at the end of the day, you have a good potential to have, to gain, to build a team and, to earn some money, right? So we decided to establish the company. It was summer 2014. Today we are in 2 locations here in Lithuania, in Vilnius and Kaunas. We have a field office which covers engineering and sales support and marketing in UK, not far from London. And we have an office, sales office and engineering support office, not far from Chicago, near St. Louis. So today we are in 3 countries and expanding further. We are more than 100 people right now. And we can say that we're truly international business. And we've been, of course, we can discuss later, but there were quite a lot of challenges to go, from Lithuania, first of all, to go, internationally within a frame of European Union, and then beyond European Union, for example, United States, Latin America, Africa, Australia, Asia. So yes, there are some interesting topics to be discussed, and I think we can cover them during the discussion later. So let's continue about the company. Our main business focuses, I should say that in the center we have platform. We have, let's say, satellite bus as a vehicle, and we offer vertical integration of the mission. So let's say customer is coming to us having only the payload, or in some cases even don't have any, let's say, instrument who will be working in orbit and asking us to create that instrument. But these cases are very rare. Our main focus is that we build a bus, we integrate it, we help our customer, to prepare it for the launch. I mean, all of the acceptance testing, qualification, etc. We take care about the launch. Then after the satellite or the satellite constellation, right, is being launched into the orbit, we commission it and then we can run it ourselves, or we can hand it over to our customers. So customer in general can do the operations himself. But the interesting thing, I mean, the main trend is like, if the customer is seeking for the service business or data related business, so in most of the cases, the customer don't want to operate the satellite himself because it contains a lot of problematic things, starting with technical and finishing, with some organizational managemental. So in general, we cover all of the upstream sectors, so to say. Of course, we do not have our own launcher, but maybe in the future we will, who knows. But despite the launcher, right, we have everything integrated right now, starting with frequencies allocation, right? We work a lot with ITU, etc., and we have good circumstances in Lithuania, to register various kinds of frequencies for our customers. We cannot say that we rent those frequencies to them, but in general, we kind of pre-register them. So we shorten the development or the legal arrangement for our customer by half a year or so. Okay, let's move on. Very shortly about our products. So we specialize, from the hardware perspective, we specialize towards nano satellite and now small satellite buses. So we started with, of course, at the very, very initial phase, it was 1U, 2U, and 3U. Soon we realized that the industry is getting bigger and the launch prices in general, globally, are getting lower. So we can, for the same price, let's say for the 3 units price, we can launch now 6 or bigger satellites. So we decided to go bigger a little bit. And now let's say our main workhorses are 6, 12, and 16 units buses. But we announced quite recently that we want to fill the gap between nano satellite and small satellite. For example, commercially available, we can find, 16 unit, and then we have a big jump towards 100, 150 kg. So we are now filling that gap with 50 between 120 kg bus, generally based on, philosophically based, right, on the 6U bus. So we have redundant versions, and we can, let's say, we can just accommodate, roughly telling, much bigger payloads comparing to 16U. Of course, during the discussion, I can provide much more details, but let's move on because the time is limited.
Yes, you have about 10
flight-proven components. We have full variety of the components. Also, what we learned through our development. When we started the company back in 2014, we thought that, okay, we will be building, flight computers and that's it. And, we were drawing the curves of growth to our, investors like this, just based on the flight computers. But that was not true. And industry was by then already quite good supplied by pretty mature components. So we started to think, how we can avoid that bloody competition in so-called red ocean. So that's why we turned our focus towards the buses once again. Also, quite an interesting thing happened, that a lot of support from European Commission and from Lithuanian local authorities came when we were developing novel green propulsion system. So roughly telling, right now, this thing is based on ADN, ammonium dinitramide, and we use thrusters from ECAPS, from very good, Swedish company, which were developing miniature 1 Newton thrusters. So we've been also working for quite a long time to offer to the industry this kind of the propulsion system, because, constellations cannot work without propulsion. You cannot synchronize, you cannot do a lot of things, you cannot keep the station let's say in desired orbit without the propulsion system. So this was also pretty important
so thank you so much
in our business development.
Thank you so much,
Launch
Vytenis.
integration,
so
yes.
Your
Let's
time
skip
is
it.
Up,
I
so
already
I'm sure
mentioned you some things. So this is the part of what we do. Satellite operations as well. We talked about that, and now let's say we're talking here about our big vision. From the company perspective, and where I believe the entire industry is going. So,
Vytenis, you're out of time.
Okay, I'm sorry.
So
That's
yeah.
it. Then let's keep it for the discussion. Sorry, guys, I have a lot of things to tell you, and
And
yeah.
so we'll
So
keep it
thank you.
for the discussion.
Yes.
Thank you. Thank you so much for your presentation. So Vitalis took us through the different names of spacecraft. So you have 1U, 6U. We can address that during the questions. Again, you can use your smartphones to send us questions. But now we're switching over to another startup. Well, no longer a startup, huh? That was also launched in 2014. We're talking about ICEYE. ICEYE is a Finnish company, also a spin-off of Aalto University, and we have the pleasure of having Tero Vauraste, Senior Advisor and Regional Manager for Europe. So, Tero, tell me, your company is also said to advance pretty quickly, but some say it might be a unicorn. So far, you've launched 14 satellites.
Correct, yes.
And you have 158 million invested into the company.
Yes.
So, also, what is new with ICEYE, and tell us about your new technologies.
Thank you very much. So it's first of all very great to be here, because actually ICEYE is in a way from Tartu. So why is that? We have here one of the godfathers of ICEYE, Mr. Jan Brax, and he's been serving in Tartu University as a professor, and he was actually the enthusiast for ICEYE. So why is that? In 2012, what happened was that I was in a similar conference like this at totally another position, providing a presentation about Arctic icebreakers. And after my presentation, I had 3 young students, they were then 22 years old, coming over to me saying that we have this crazy idea about microsatellites and SAR data and launching them up to space. So could you come and join us and help us a bit? The company didn't exist, the company didn't have any name. The students were serving at Aalto University with Jan, and that's how it all started. So what happened afterwards was that the story started to evolve, and look at where we are now. Only in 9 years, 40 nationalities, more than 300 people working. We have 14 satellites, $158 million secured financing, existing portfolio of customers all around the world. And this actually all happened in a way from Tartu, because Jan was one of the godfathers of. So it's great to be here today to discuss this with you. As you can see from this one, it's been a great involvement, and there is more to come. So this is a great startup story, and it's actually now a post-startup story, as we are already operating. You can see the amount of funding, and for the funding I would like to address my first important message. Obviously, startups always need national funding and institutional funding in the first place to get going. And there, we would like to thank Business Finland and the government of Finland for the start, where we have gained different types of loans and fundings from there. But importantly also, the European approach is here very important. We really welcome the new European Space Agency strategy and Vision 2025, which is linked to the European Commission statements from last May, where they state that there will be new space approach highly appreciated. And this is important when we compare the competition between the US and the European markets. So if you have a look into the national funding from the US to the US startups compared to what's been available in Europe, Europe has been trailing. So the new ideas from ESA and new ideas from the European Commission are really important for the next ICEYE of the European sphere. This is just an idea of the SAR image. So synthetic aperture radar image, the best thing for that is that it sees through clouds, it sees through darkness, it sees through rainfall. So whatever the optical obstacle is, the SAR image gets through this obstacle. And this is the main benefit comparing SAR images, synthetic aperture radar images, and optical images. And this gives you the idea. On the left side of the image you see clouds, on the right side of the image you see how the thing and the ground looks. The current Director General, Joseph Aschbacher, said a couple of years ago that having SAR on small sats is not possible. Well, ICEYE was the first to do that. We do have some rivals, which is really good because that keeps us running even faster than the forthcoming rivals are doing. So the vision for us is to help the decision makers to get better decisions with the help of SAR data, with the help of new types of analytics and images available. It's proven, it's working. Even some of the first satellites up in the orbit are still working. Year to date, we have launched already 14 satellites, and there is more to come. So we're in a path to more than double the number of satellites within the next years to come. So the constellation will grow, which will give you improved frequency, improved opportunities of getting images from your areas of interest many times per day. Here you can see the bus where the most recent satellites were launched. So with the EXO launch, we used the help for that going. And here is like the video out of that. And unfortunately, that's not working. But you can see from the YouTube where the launch was conducted. So it's really a great video. We do have different types of image modes available. This gives you an idea out of that 5 times 5 kilometers to 30 times 50 kilometers up to 100 times 100 kilometers depending on the need, whatever you have over there. We recall that there was a fall on the volcano a couple of months ago, and we did interferometry work for this one. So we can have a great video of what happened with the volcano in Iceland. And by comparing different images to other images, you can make like a comparison and detect the changes. So we started this already in advance of when the eruption started, so you could have a look into what really happened in the soil over there. Oil spills, another example. Gulf of Finland, important area both to Finland, Russia, and to Estonia. We can detect those with the SAR images. We can detect vessels in the area, perhaps have a look into who's perhaps responsible of that. Different types of images where you can have a look into the quality of water. This is, for instance, from the St. Petersburg area, again, quite near here. We can do sea ice monitoring. And by the way, this is where the name of the company initially comes from, ICEYE, because that was the initial business idea. So let's have a look into how the ice develops in the Arctic areas. And that's why it's ICEYE. Well, very rapidly it was acknowledged that, well, yes, the satellites do go around the globe, so we can also work in other areas. But ICEYE is a good name, and we say ice is nice, so we will keep that name. Different types of ice images available. This is from the Quark area. Here again, another example out of those. From the Antarctica, a great example as well of the developments. You can have a look how the ice develops over there. A lot of customers around the world, support from different types of US institutions, US clients working with URSA, obviously with the European Space Agency, our important collaborator. You can have an access as a researcher to our images through the European Space Agency third-party mission, whereas once you're a researcher, you get the images free of charge, funded by the European Space Agency. We're also working in the future with the Copernicus contributing mission, so you will gain access to our images over there, and obviously there are commercial opportunities for gaining the image access as well. Thank you very much for having the opportunity to discuss with you today about ICEYE. Thank you.
Thank you. Thank you so much, Taru. This was very interesting. Now it's my turn. So we've been talking about satellites now and space technologies. How do you know how space can affect your lives, and what type of data do you use in your day-to-day lives? Google Maps, anybody? When you see the terrain, those are satellite images. They're not drone images. Here in Estonia, we have different types of companies who work on these types of technologies. So, as Arthur was mentioning previously, I work for the European Space Agency, and my responsibility in it is to be the country manager for Estonia, but overall provide the strategy understanding of what's happening with the 1,200 startups that we have selected over the 22 ESABICs in Europe. So we can see that the majority of these startups actually are not rocket scientists. They don't need to launch rockets into space. They use satellite data to be able to make your lives better. We have approximately 10% of these startups that are into drones, into aviation, another 10% in Internet of Things, and also agriculture and food, because that is a very important direction that is developed in Europe right now. What about Estonia? What about Estonia? We have an ESABIC here in Estonia, and we have now selected 19 startups already since the start of the contract 4 years ago, and they have been doing actually quite well. For example, one of our companies is Golbriac Space. They raised a lot of money. You can ask them how much they raised. And we have also the Kratworks, who just raised 1 million. So really, it's a very different spectrum of companies that can apply to be an ESABIC. What what do you need to do to be able to apply to an ESABIC, and what are the benefits that you would reap from it? Well, you need to have a space connection. So you need to either use satellite data in Earth observation, telecommunications, or geolocation. And then you need to present a business plan. What we have to offer is 2 of the greatest incubators here in Estonia, one in Tallinn and one here in Tartu. And we offer 50,000 euros to grow your company and to be incubated for up to 2 years. For now, what we are looking for the future is to continue this cooperation with Estonia, because it is really important that every ESA member state would have an ESA business incubator in their country. Right now, we are currently talking with Poland, and we're expanding to other countries, and we have several interesting conversations around other companies in the Baltics. And overall, our companies here and over the world, over Europe, have been leveraging not only on ESA funding, but also on other types of funding, like the EC's funding. For example, here in Belgium, one of my companies was an ESABIC incubatees, and then ESA helped them grow, and then the European Commission continued to make them grow with different types of funding, and they can finally go to space. Because in space, if you're in the upstream part, if you have we have more than 100 companies that are really in the upstream, that are developing the satellites and subsystems, and for those we are trying to give them as much support as we can. However, sometimes it's proven difficult, because space is a difficult business to be in, and this is why it is very important for public agencies to support space in Europe and overall. Should I jump to questions directly, or do you guys want to hear more about ESABICs? Our representative from the ESABIC is Sven, just over there. Can you show us? Yay, Sven! So if ever you have any questions about Estonia, please ask this guy. He knows everything and everyone. And if ever you have any questions for any other countries, we have also ISABIC Bavaria present, and ISABIC Austria, and we have also startups from these companies, from these countries. And I think we can jump into the questions. I have a lot of them on the app, so that's why I'm thinking that that would be more interesting. So I think the first question was, yes. So Tero, how did ICE survive between 2012 and 2017? And what kind of funding was available to you then?
Okay, the company officially started as a company 2014-2015. So from 2012 to 2015, it was like a pre-startup period. The first fundings were received through Finnish national mechanisms from Business Finland, supported by the European Space Agency, but very rapidly after that, commercial funding was available. And as you recall from the slides, we have conducted 3 financing rounds, which are fully private. So we are now invested private and owned privately also internationally. We have survived very well the different, I would say, difficult times of COVID, but also taking into account the fact that the satellite building requires obviously lots of investments and investors. So survived well with these both national and private mechanisms.
Thank you, Tero. Another question is for Vitanes. Do you remember your first fundraising, and what did you learn from that?
Yes, I remember very well. We started to fundraise right after the company has been established, and it was like, well, fall of 2014. I think the biggest lesson is that you shouldn't be afraid of your ideas. And we started the company in Lithuania, where the country which doesn't have too much of traditions related to space business. So we've been a little bit maybe too conservative, kind of expecting from ourselves a lot. So we could have been a bit more relaxed, but everything went well after all.
Okay, so your suggestion is to be relaxed for a funding, for a fundraiser?
No. Think bigger. My suggestion is always think bigger. Don't be afraid to think big.
Okay. Another question is for you, Jan. In the playground of innovation in new space, how do you evaluate novel technologies? Which one should we develop, and which one don't have a future?
So this is, of course, very difficult to tell. If I would know that beforehand, I would perhaps be a millionaire already. But I think we need to progress on the larger front, and time and need and the world will pick what is exactly needed. So we are not even able to identify all the future needs. And for example, ICEYE radar, there was no market for such a small SAR satellite before, and people were basically laughing like, yeah, we have SAR satellites, what's a big deal? But it is a big deal. So I think we just should be brave and develop very large variety of different technologies.
Right. So when you evaluate such technologies, for example, when people come with crazy ideas to us for TEBs, we sometimes are reluctant to think, okay, well, first, there's no market for these guys now. So do you keep your just eyes open, or do you think that there are some trends that are coming?
Yes, I think what we should do is, of course, there are several levels for funding. If we go to the ISABIC level already, of course, we expect that there is a commercial potential. And anything which we want to develop before that, it should be probably belonging to universities. So what I'm telling that we should have also programs for universities to play around with various things. We are very happy to have this kind of funding available in Finland. So ICEYE was able to start. And then if they are mature enough, they can go to the actual business. And then, of course, the business plan and market is very important. So we sort of have like many fronts and many layers of funding, and ISABIC has an important step to take it from the research money and risk money to actually happening something towards the markets.
Yes. That is something that we have been discussing overall, is the fact that there needs to be a little bit of a push for technology transfer from development into supporting startup companies. And then I believe we also spoke about, well, I was mentioning the different trends that we have. From what I've seen, some of the trends are into digitalization and also constellations. So, well, Starlink, of course. But Tero, one of the questions was, how many satellites do you need to still launch for the constellation to be fully operational?
Yeah, so as we recall, we do have launched 14 satellites,
yes.
And there are around 4 more to come later this year. There is a launch plan for the next consecutive years, and actually the constellation is already ready and it's never ready. So obviously we keep improving that, and once time goes by, all the satellites will be demolished from the service, so we also will be needing replacements. But in order to have all the response requirements from the customers well responded, I would say that we will be within the line, plus minus next 2 years, doubling the size of the constellation, going plus 20, even plus 30, and probably more to come.
But this would be, this extension of your satellite fleet would be to monitor specific zones, or do you, are you going to have a global coverage, and maybe are you developing a special tool that you're going to be using?
So all the satellites go on polar orbits, so basically it means that they go around the globe and the Earth rotates underneath. Okay, so that already gives us a global coverage today.
Yeah.
And the closer you get to the North Pole or the South Pole, the better the frequency for the images is. For a specific area, say latitude 65, you might be able to get 10 images from the same spot during a day, already today. However, we also have now 2 satellites on so-called coherent ground track repeat, meaning that the satellite can take an image from the particularly same spot with a time difference of 24 hours. And then you can make, we call it a change detection with interferometry, whereas you can see what things have changed and what has not changed between these 2 consecutive images. Say that, for instance, if a vehicle has left the area, or if another vehicle has entered into the area, or if there is a change in the soil, which we saw, for instance, with the volcano. So that's something special. Also going towards providing video, we have a collaboration project with the European Space Agency of developing that as an example.
Thank you, Tero. And Vitanis, a question for you, a follow-up on this one. So for us, the most important part is to get data from satellites quite often, right? So we are talking here about every 24 hours. For your company, are you developing any parts of subparts of satellites that would make agility easier, or do you think that everything that is on the market is currently the best it is, and do you think that now you're going to concentrate on satellite buses and integration?
The technology, of course, never stops, and it always, constantly develops. So for the ground station networks to download the data, we work mostly with KSAT, for example. And working with KSAT, we have broad variety of frequencies we can utilize to download the data. Of course, there are some regulatory issues. It's not that easy, for example, to use Ka band for, space-to-space communication. It's easier, to use it for ground-to-space communication. But then you have other challenges. Pointing, antennas, etc. So yes, we do develop some things. Currently, I should say that the main thing from the practical perspective is to squeeze everything from the S-band talking, about the data. From the, let's say, technological, philosophical perspective, of course, people are exploiting QV, Ka, bands, X bands, etc. But from the practical perspective, I mean, price versus ability to download the data, I should say we still have something to do with S-band and to squeeze, maximum out of it. Of course, people are also working on laser communication, which is distant thing and really into the future. But yes, I mean, all of the environment today allow us, let's say, nano satellite and small satellite manufacturers to think, towards the future, expand, accelerating the download data, etc. So if I answer your question.
You answered part of it, a part of it. Thank you. So one of the one of the interesting questions here is to all of the board members: what personality traits and behaviors do you think make a space engineer? So I would say that we don't only need space engineers, we need space entrepreneurs. So I'm going to ask for space entrepreneurs and engineers. Jan, do you want to start?
Yeah, let's go to Mars, like perseverance, ingenuity, a lot of good qualities, of course. But yeah, I think people need dreams as well. So space is a especially dreamy business, let's say, and I would like to see people with a vision and dream in the business.
That sounds interesting. How about you, Tero?
Crazy enough and able to stay awake for at least 72 hours.
That reminds me of things I want to forget. How about you, Vytenis?
Well, I should mention, I think, three things. Of course, the right, let's say, technical skills is not enough, and education is not enough. Any kind of person, whether it's businessman or engineer or manager or whatever, it should be persistent, it should be fierce, right? And it's not enough to be good. I mean, that person or the company or anything should prevail. So these are the things which drives everything forward. And since the industry is running fast, well, you cannot be slow because you can be overtaken at any moment by your competitor, for example.
Understood. I would agree with that because from the experience that I have working with space startups, you need to be able to respond very fast. So you need to be fast on your feet. And also, I would say that you need to be able to put yourself in different types of shoes. So your engineering guys are also always going to tell you, yes, but we need this types of specifications and they need to be top notch. And then you start doing the calculations and you realize that that does not fit with the business plan. It does not fit with the amount of money that you have available. So I would say flexibility is a very important one, and also to be sure to not take no for an answer, I would say also, because perseverance is something that is very important. Now, some other questions that we received, which are a little bit interesting, I'd say, not the usual ones we would see at a panel, is a very not controversial one, but almost. Who would win the race, OneWeb or Elon Musk? What are your thoughts on that, and why do you think would that be the case? To whoever wants to answer.
I would put my money on Elon Musk because he has launchers and satellites, and this is an ultimate combination.
That's true. And
why wasn't ISI the third one in this race? I would bet on that.
Okay, we have one vote for ISI then. How about you, Vytenis?
I think I would vote for Elon Musk. I mean, the guy doesn't care about the obstacles.
Yes, true, but yes, that's good answers, I think, all of them. So I think I've had all of the questions. One of them is quite specific, so I think it might not be applicable to anybody. It's specific in the audience, but if ever you have any more questions, you have 5 more seconds for me to refresh this, and otherwise, I'll just say thank you to all of the 3 panelists today. So we've learned how important it is to be innovative and to inspire students, how important it is to persevere and continue with the correct idea and propose also new solutions. And Vytenis, thank you so much for attending and explaining to us how difficult the path is to actually getting to where you want. And we hope you succeed in becoming the next Airbus. Thank you so much, everybody. Have a great day. Bye. Oh, and we have goodies at the ISA Big stand, so please come and see us. And also the space, there is a bar over there, and the happy hour starts now. Thank you. Bye.